All right, scrolling down to page 2 of the review, it says evaluate or simplify the expression. So here we're taking log base 8 of 2, and we are trying to figure out what this number is, right? So we're saying 8 raised to what power is going to give us out 2. In this case, 8 is a perfect cube of 2. So if we cube rooted 8, right, we'd have to go 1/3, 8 to the 1/3 to get out 2. So then to evaluate this log, the answer is 1/3. Number 12, we're saying how can we make 2 become 1/2 by raising it to a power, right? 2 raised to what power gives us out 1/2? In this case, -1. Okay. 14, maybe a little bit harder because this log doesn't have a base, but we have to remember that's the common log. So this is really log base 10 of 1/1000. 10 and 1000 are super related. That's 10 times 10 times 10, so that's 10 to the 3rd power is 1000. But then we need to put the 1000 in the bottom, so that means our 3 has to be negative. So then this is going to be log of 1/1000 is going to be -3. And then lastly, we have 15 here. The easiest way to do 15 is that this ln and this e are going to cancel. The only thing that's left is 2/3 x. Okay, but if you want an explanation of how that works, right, this 2/3 x drops to the front because of our power property. So 2/3 x multiplied by ln of e. We know that ln has base e, so e raised to what power gives us e? Just 1. So this is 2/3 x times 1, which again takes us to this 2/3 as our answer. Next up, it says find the inverse functions. I prefer to do these inverse function questions by actually physically solving for y here. So here's what we're going to do. We're going to switch the x and y. We're going to say x is equal to the natural log y minus 2 plus 1. Now we need to solve for y. We subtract 1 from both sides, and that's going to give us x minus 1 is equal to ln of y minus 2. Now that the natural log is isolated, we can e both sides, so we e here and we e here. Natural log and e will cancel to leave us with y minus 2 on the right side. On the left side, we have e raised to the x minus 1. And then you add 2 to both sides to get e to the x minus 1 plus 2 is equal to y. And there's our inverse function. Okay. For the next one, again, we're going to swap x and y. So that's going to give us x equals 3y plus 2. And then we need to solve for that y. So when we're solving, when there's an variable in the exponent, we're actually going to take the log of both sides here. In this case, we're going to go log base 3 so that we cancel out that 3. So log base 3 of each side. So that gives us log base 3 of x is equal to log base 3 and 3 cancel, so y plus 2. And then you subtract the 2 to get log base 3 of x minus 2 is equal to y. There's our inverse equation for letter B, I mean. And then lastly here we have letter C. Switch the x and y, so x equals log base 4 of y minus 3. We need to isolate the log before we can solve for it, so that's x plus 3 is equal to log base 4 of y. It has a base 4, so if we exponentiate both sides with base 4, it'll cancel. So we have 4 to the x plus 3 is equal to y. And there's our inverse function. Number 18 says graph that log function by first graphing the parent function. You don't need a dashed line. I'm good with just plotting the points of the parent function just to show me you know where it is. And then showing how the graph is translated. Be sure to show at least 2 specific points, state the domain and range, and give the equation for the asymptote. So this function is a log function that we're graphing. So our parent function is just y equals log base 3 of x. And you can remember, if you need to switch this to exponential form, do it. So we have 3 raised to the y is equal to x. And then we're just plugging in some y values to get out good x's. And I always like to plug 0 in for y because that's going to give us out a 1. If you plug in 1 in for y, that'll give us out a 3. And then we can plot those 2 points. So 1, 0, and then 3, up 1. Remember, our vertical asymptote always starts here at x equals 0, and then it shifts with the horizontal shift. So x equals 0. And now let's do all the transformations. In this problem, it's telling us to translate it left 2 and down 1. So we'll start with the asymptote here. So asymptote moving left 2 would be x equals negative 2 here, and then each point left 2, down 1, left 2, down 1. And then there's our graph. Boom. Our asymptote we decided was x equals negative 2 because of the shift to the left 2. The domain in this case, it goes from negative 2, but not including, all the way to positive infinity. And then the range is all real numbers. Remember, the log is the inverse of the exponent or exponential function, so their domain and range is going to flip. Okay. So in this next part, it says let log base b of 10 equal 3.329, and let log base b of 6 equal 2.581. It says evaluate each expression. Number 19 would be a calculator question, so I'm just going to pop out Desmos right here, just so that I have it and can be using it as I go through these questions. So log base b of 10 is going to be, there's 2 ways to look at this question. Right, that's either the log base b of 10 squared, or you could imagine it as the log base b of 10, log base b of 10 multiplied by 10, because we know both of these properties. Power property moves the exponent to the front, so it becomes 2 multiplied by log base b of 10, which would then become, what is going on? Which is then going to become 2 multiplied by 3.329. And then we just type that in, 2 times 3.329. And so our answer for letter A is 6.658. In our other instance of this problem, where I did log base b of 10 times 10, then that would become log base b of 10 plus log base b of 10. So then we're just, stop opening Canvas. So then we're just 3.329 plus 3.329, and then we would still get out 6.658. Okay, letter B. Couple ways to think of letter B as well. I like to just think about the property of division, right? It becomes subtraction, so log base b of 1 minus log base b of 6. Whenever you take the log of 1, b raised to what power gives you 1? It's always going to be 0. So 0 here, and then minus log base b of 6, which is 2.581. So 2.581. So then our final answer is just negative 2.581. All right, lastly here we have letter C. Letter C, this 60 splits up into 6 times 10, so that's log base b of 6 plus log base b of 10. So then log base b of 6 is 2.581 plus log base b of 10 is 3.329. And then we just add those together. 2.581 plus 3.329. That would give us 5.91 would be our final answer there. All right. That ends the calculator portion of this first half here. Man, my iPad's moving slow. Number 20, it says write the expression as one logarithm or condense this logarithm. Remember, whenever you're condensing a logarithm, you need to put up the exponents first. So like this 5 needs to get put up on top of the z before we can combine. So that is log of 9 plus log z raised to the 5th. And now we can combine these two logs because they have the same base. So that's log of 9 multiplied by z to the 5th. And then we're condensed. Expanding number 21, it has to get cut anywhere there's a multiplication or division sign. So that tells us there's going to be 1, 2, 3 separate logs. So this is the ln of 3 plus the ln of y, because that's how you split multiplication. And then we'll subtract the ln of x to the 5th. We always have to remember that that 5th power can get dropped down to the front. So this is ln of 3 plus ln of y minus 5 ln of x. Then we're good. 22, it says use the change of base formula to evaluate log base 6 of 7. All right. Change of base formula, hopefully you remember. Because the 7 is on top, we're going to say that it's the log of 7. 6 is on the bottom, so divided by the log of 6. Grab our calculator out so that we can finish this problem. That is going to be log of 7 divided by log of 6. And that'll give us 1.086, I guess we can say approximately, because we rounded. Okay. And that is going to be it for page 2 of the review sheet, and then we'll be rolling on to page 3.